So let's create the system. We have our entity, our tank entity. We have our components on our tank. Now let's make a sprite system. So this dot sprite system, create sprite system. This is the function we made up here, right? Create sprite system. We're gonna pass in the scene. In this case, it's this, and an array of textures. Welcome back to Arcade. I am Super Tommy, and I think you guys are gonna like this video. People have asked about this for a while, and this is the entity component system video in Phaser 3. Now, Phaser 3 does not have a entity component system built into it, but you could still use that pattern to make games if you'd like. Now, I've decided on a entity component system framework. That was one of the hang-ups that I've had for making this video, is I didn't know which one to cover. There's so many in the JavaScript ecosystem. The support is so across. There's some more popular than others. There's some that look like they were popular and then they're no longer supported. So just looking forward here, I've decided that because Phaser 4, coming sometime next year, probably, actually, I guess Rich doesn't know. So the team doesn't know, so I'm not promising anything. I'm just guessing. Phaser 4 is gonna have ECS built in, and they're using bitECS. So here's Phaser 4. And Phaser 4 is using bitECS, at least for now. I don't know what the plans are specifically. But you see they're using bitECS. Phaser 4 is, of course, very early. Things are changing a lot with Phaser 4. And so bitECS is this fairly new entity component system framework, but it does seem extremely fast, which is great. So this is bitECS here on GitHub. And so it's, of course, only at version, I think, 0.3.10. So it's also very early. So these are two very early technologies, Phaser 4 and bitECS. So we're not looking at Phaser 4 in this video. We're looking at using bitECS in Phaser 3, since there's way more features in Phaser 3 so far. If you're making games, Phaser 3 is definitely the better choice currently, just because there's more support and things are not changing that much. And in Phaser 3.50 plus, or the 55 releases, these all .50 releases, have been fantastic, and there's been adding more features, more bug fixes to Phaser 3. So Phaser 3 is a more mature, great framework to use to make your web games. But if you want to use ECS, using bitECS in Phaser 3 is possible, and will basically give you a leg up when Phaser 4 comes around. It'll have a similar, what's going to use bitECS from what I can tell. And if that stays the case, you'll have a relatively good understanding of how things are going to work, how things can work in Phaser 4. So it just makes that jump from Phaser 3 to 4 a little bit easier if you're already using, or if you're wanting to use, a entity component system framework. Using bitECS will help you in your Phaser 3 game. So what we're actually going to do in this video, or this probably series of videos, I'm going to try to go over how entity component system works, and largely show you how we're going to do something very basic using bitECS to get a tank on screen, and then we're going to have some tanks move around. So here's a demo of what we're going to largely want to have. Oh, sorry. 8001 is the demo. So these green and red tanks are moving on its own. It's like a very, very simple AI. It just randomly picks a direction and moves. And then the blue guy is actually the player. So I'm pressing the arrow keys and I'm moving my player tank, and that's the blue guy. There's no collisions or anything like that. This is just to show you how to get your player to move in an ECS framework, or ECS system pattern, and then how to get these AIs to do other things. So how you're operating on a whole bunch of tanks, or entities, right? That's what this is called. A whole bunch of entities, and have them do things. In this case, just randomly move around. That's what we're going to end up with in this series of videos. So let's get started. Go small. And let's get started by going through how we can set up a bitECS world. Let's get this size. Let's get our console up here, or DevTools rather. So here is bitECS, and you can go through the getting started that they have. if you want to, but we're going to basically do a very similar thing here. And start, but put it inside Phaser 3, like a Phaser 3 scene. So what we have here in our project is a Phaser 3 scene, just a relatively empty game scene. We do load these 3 images. So this is the blue tank, green tank, red tank that you saw. And so just from within the scene, we're going to put bitECS into the scene. So we're going to run the ECS world within a Phaser scene. So we're going to use the update loop provided by Phaser. Now you may be able to do it the other way, where you have bitECS on top and then Phaser like under it, so to speak. In our example here, we're going to put bitECS inside Phaser. I think that's easier to manage and to think about, so that's how we're going to do it here. So first thing you want to do is create entities, but really what we got to do is create a world first. So in bitECS, you need to make a world, and you can make as many worlds as you want, and entities belong to worlds. So let's make a world. So we're going to import. Oh, so I've installed bitECS, so you just do npm install bitECS. You can probably find that here somewhere. npmi bitECS. So we're going to import a bunch of things from bitECS. First thing is create world. So let's make a world here. Const world. Create world. Now there are some settings, but we don't need to really do anything with that. Let's create world there. So now we have a world. Now we can add entities to this world. So we're going to do add entity, which is another function from bitECS. So let's just say this is our player tank. We'll call it tank. Add entity. We're going to give it a world. So every entity is added to a world. Now, you may think, if you've done Phaser 3 before or most other game engines, when you make an entity, it's like an object that you can maybe see on screen, but that's not the case here. This entity is just an ID. It's just a number. There's nothing visual about it. It barely exists. It's just a number. It's an ID that we'll then use to look up a whole bunch of things that make up this this entity. Like usually it's going to be components that define what properties are on it. And in ECS, we have systems that then operate on each component to do whatever it needs. And that's how your character can move, how you can take input and move your character, how the CPU or how the AI can move the tanks that we saw. So that's how this works. So this entity is just a number. It's nothing more than a number. Now we can add components to this entity. So let's just whip out this add component function. So these are roughly the core. There's one more core function from bitECS, that's create system. But for here, from world entity, now we want to add a component. These are at least 3 of the main things you need to do. So we're going to do add a component, and you get a world, you give it a world, you give it a component to add, then you give it the entity to add the component to. So we do world. Here we don't have a component yet, and the entity is this tank. So let's make a very simple component. We're going to call it position, since our tank is going to need a position in the world. So I'm going to do it up here for simplicity right now, but we're going to move these things in 2 folders so that you can make a whole bunch of components that can be shared across multiple entities, multiple projects really, since they're only data. So in ECS, different than the component pattern that we've covered on this channel, or it's called entity component sometimes, which adds to the confusion between the older component pattern and the more modern entity component system ECS patterns. So just to clarify here, our components in ECS are only data. There's no logic in there. It's only data. And in the world of bitECS, the data is only numbers. So let's just go ahead and do it and see. Just check my notes here on what my position is going to need. Right. Okay. So we're going to do position. And we're going to use the create component, define component function from bitECS. Define component. Define component, and it's just going to be an object, so it's a schema. And in a bitECS schema, you can have any property you want, but all the properties are going to be of some number type. And these are like typed numbers, so like unsigned ints, float 32, int 32, I think int 8, unsigned int 8. So they're like 8. I'll just show you. It makes more sense this way. So position has x, and we're going to need types here. Types x. So types. So for a position xy, so here you see, like I was mentioning, here's float 32, float 64, integer 16, int 32, int 8, uint 16, uint 32, uint 8. I forgot what uint 8c is. I think it's clamped. We can look that up. So these are like the options you have when making properties for a bitECS component. Now there's reasons why bitECS does this, and it's for performance. You can read their GitHub for more on that. But in our case, for position, we're going to want it to be floating point of some sort. Let's just keep it as float 32, because we're not going to move too much. The world is not going to be that big. We don't need to we don't need a 64-bit float. All right, types float 32. So this is our position component. As you can see, there's only data on this component. There's no logic to it. We're simply defining a thing called position, and it happens to have an x and a y, and the x and y are of type float 32. So that's our component. That's it. That's all it is. Now when we come here in our add component, back down here, we can do this position, and now we've added a position component to our tank entity, and our tank entity is just an ID. So now how does this work? How do you give it an x and a y? Right, if you can't do like, position, like this doesn't return to you anything either, right? It's a void. So in our previous component pattern videos, you can of course set values on that component. Like that component is itself a class object or a class instance, and we can set values on it. But in this case, what we have here is a structure of arrays. That is to say, where normally if you wanted to, you have an array of structures. So previously in our components, you would add components to like an array of components for this entity. In this case, we kind of inverted. So what we have here, if you go to position dot x and dot y, and you see these are float 32 arrays. So that means, just highlight this here. It's a float 32 array, so position.x itself is an array. And so what you want to do in an array is, of course, index into it. And the index for this array is this tank ID. So that's the index that we're using. So if we do tank, this is going to be the x value for the tank. Let's just say 100, position.y, tank, and just say 100 as well. Let me just double check I'm not leading you astray. Yeah, I think that's correct. Okay, so now that's how you set values on that position component for your tank. So there's an array of x values, an array of y values, and you index into it on the ID of your entity, which is just this number. So your entity is just a number, and that's how it indexes into this position component array, this float 32 array. Okay, so we have that. Now we're not going to really see anything. We can console log this. Let's do that. Console.log position. Let's go to our test here. Let's see what we got. So we've got this pre-allocated, what is this, 10,000, 100,000, 100,000 slot array, and we've indexed probably into 0 is my guess. Let's break it down. Yep, so this is x, 0, 100. And so that's how this ECS works. We're indexing into this array, and for each entity we have, it's going to have a entry in this array representing the data for that entity. So you see that did work. So now, so we did the create entity, we did create attached components. Now we can do something with position, but by itself there's really no system we need to make. So let's make another component. Let's call it velocity. Const velocity. We're going to do define component again. Now in our case, you could probably share this because velocity and position are just the same thing, x and y. But we'll just do it this way. Types f32, f32. And we're going to add a component, this velocity component, to our tank, just like our position. And we can give our velocity something, let's say velocity.x, tank, let's just say 1. Velocity.y, tank, let's say 5. One is slow. So this is xy velocity 5, so that just means it's going to go like this way, diagonal to the southeast direction. So that's our velocity. Now, you see we don't see anything. We created a world, we created an entity, we attach components, but we don't see anything, and nothing is happening. So let's go over how we're going to have it draw things, because what's a game without things being visually seen? So since we're basically bolting bitECS on top of Phaser, we're just going to use existing Phaser rendering. We're not going to do anything fancy here. We're just going to use Phaser rendering. So we're going to create sprites. Now for simplicity, we're just going to make it all sprites. And so we're going to add a sprite system and a sprite component. So let's add a sprite component first. Yeah, let's do that. Sprite. Define component. Now, normally in Phaser, if you wanted to make a sprite, you would give it this key, tank blue, tank green, as to what texture it should use. Now in bitECS, all of these types can only be numbers. So what we can do is give it a number. So we're going to call this texture, and we're going to use types uint 8. And so we're going to use the smallest unsigned int that we have access to here. Just got to check what that C means, I don't remember. But this is uint 8, so our texture number is never going to be negative, right? So because what we're going to do, actually I'll just show you first, but just it's easier to show you than explain this, but our texture number is never going to be negative, since we're going to basically index into an array of strings to know which texture our sprite is going to need. So we're going to use the smallest number possible. I think U8 unsigned int 8 gives us, I want to say 255 numbers. I could be wrong, but that's more than enough. So let's do add component world sprite tank, and then sprite.texture our tank, and let's say it's going to be tank blue. So tank blue is 0, right? We can use enums to make this easier to read, but let's just show you what's actually happening for now. So 0 is going to represent tank blue. Tank blue. We're just going to say tank blue is 0, tank green is 1, tank red is 2. So these are just numbers representing texture strings. Now let's create a system. So we're going to do define system. All right, and we're going to call this our sprite system. Define system. It's going to give it a function. Let me just double check the notes here. Sprite system. Okay, so we're given a world. And so our system is just going to be one function. We're given a world. There's some extra R's if you want them. And what we're going to do in our sprite system is we're going to have a map of sprites, their ID, mapped to an actual Phaser sprite object. So let's do sprites by ID. I'm going to make it a new map, number Phaser.gameObjects.sprite. Right, so what we're going to do is each time we create a sprite, we're going to give it an actual phaser sprite so that we can draw it. And now to know when this happens, basically when this add component happens, we want to do it one time, insert an actual sprite, a phaser sprite, into this map. So what we can do, there's a query. So in ECS systems, you can generally query for entities that adhere to some number of components that they have. So in our case here, we are going to do define query to make a query. Define query. Let's call this the sprite query. Define query. And give it an array of components. So in our case here, let's just start simple. Our query is going to just be if you have a sprite component. And then when we come in here, we can do with this query. So sprite query. We do sprite query. Give it the world. It's going to again return to you a list of entities that have this sprite component attached. In our case, we have one entity, so it's just going to give us an array of one value, being the ID of that entity. But what we want is to know when it first adds that component. So in bitECS, we also have a enter. So let's do sprite query enter, and then we can do, I think it's enter query. We do enter query, and then we pass in the query that we want, in this case the sprite query. So now each time a new sprite component is added to an entity, it's going to be given to us in this sprite query enter. So any entities that just got a sprite component added will be returned by this query. So we can do this. So let's just call this enter entities. We're going to do sprite query enter. Give the world. So this is going to be a list of numbers, and we can do for enter entities dot length. Let's do that. So now we're going to get the ID. That's going to be enter entities I. So that is the ID of the entity. So this ID is basically going to match this. And so our sprites by ID dot set. We can check if it has, just in case something went wrong, but for simplicity here, we're going to do a set. And we're going to need to access the scene here. So given that the system is going to be defined outside, you could define it inside this class, but we're going to define it, in a separate file somewhere later. What we can do is create a function that creates a sprite system. So instead of this, we're going to do create sprite system, and then this is going to be, let's just call this function, and we'll just call, and then it will return define system. So this will create a sprite system. And so we're going to actually give it a scene here, phaser.scene. That's how we're going to get access to our scene. So with that, we're going to do scene.add.sprite. And let's just say 0, 0. And we need to know what the texture is. And so that's what this here is. Right? So our sprites components, so sprite.texture ID, that's going to give us the texture. Let's call it text ID. And we want to know what this text ID represents, so we're going to actually pass in a thing called textures. Boom. And that, nope, this is going to be string. And texture is going to be textures, text ID, and texture. Okay, let's see what it's complaining here. Let's see, void is not, oh yeah, we need to return the world. And so for now, this does nothing. So let's just do that. Well, I guess we can leave it. Doesn't matter. So our Sprite system, Sprite query here. Now we got to make one. So let's come to this class. We're going to do private Sprite system, and it's going to be a system. I think there's a type for system. Let's see. Yeah. So let's import system, and it's just going to be a system. And we're just going to let's just say maybe it's not created. So let's create the system. We have our entity, our tank entity. We have our components on our tank. Now let's make a Sprite system. So this dot Sprite system create Sprite system. This is the function we made up here, right? Create Sprite system. We're going to pass in the scene. In this case, it's this, and an array of textures. So we call these tank blue, tank green, tank red. So this is our Sprite system. Now we gotta run each system. So this dot Sprite system. Oh wait, yeah. We also gotta save the world. Let's do a world up here, private world, and get a type, iWorld. iWorld. Let's do this dot world. So we're just replacing our local world variable with a class property so that we can access it in update. So if not this dot world or not this dot Sprite system, return. And so now we're going to run our Sprite system. We give it the world. Alright, so let's just double check here. Got our system, our Sprite system defined system. We've got a for loop. And missing this, I less than. Alright, we go through all the entered queries. We're going to do something with this later. And save that. So I think when it was running with this, this is actually in an infinite loop. And so, can I refresh? Close this tab. Tab close. Okay. Try it again. Alright, so here we've got this blue tank up here, as you can see. Now it's up there because we're not using the position component to, get a position and then set it. So what we can do in our Sprite system here, where we do define query, we can say we also want anything with a position component. And in our case, we only have one tank, we have one entity, so it's not really going to do anything. So let's make a difference rather. We only get one make a difference because we only have one entity and it happens to use all the components that we just made. But let's just get here entities, it's that, and let's do another for loop. 0, I less than entities dot length. And we're going to go through each entity, and what we're going to do is basically set the position for the sprite. So we'll do ID, and then here entities I, so that's the ID of our entity, in this case the tank. And we want to get the sprite, so sprite by ID dot get ID. So let's call this sprite. Then so that's the sprite. So sprite.x. This is just a normal phaser sprite. It's going to be, that could be undefined. If not sprite, let's just continue. So sprite.x is going to be position. So just like how we set the x before, we indexed in to the x array. We're going to index into the x array now to get that x value. Sprite.y, y. here it is at 100, 100. So now we have a basic working system. So let's just go over here. We're still going to want to add an exit. Let's just do that first. So just like this enter query, there's also an exit query. So enter query, exit query. So what we want to know is when a sprite or when an entity no longer has a sprite component, or it's going to be destroyed, or whatever happens where the component is going to leave that entity. We want, so let's just call it sprite query exit. So we do an exit query on our sprite query, sprite query, and this is going to give us all the sprites, all the entities where the sprite component has been removed from it. So let's see, call these exit entities, sprite query exit, give it the world, and it's going to be basically like these two, where we're going to do a for 0 I less than exit entities dot length plus I. Here we're just going to remove the entry from our map and basically destroy that sprite. So we're going to do d exit entities I. We're going to get the sprite, by ID dot get ID. But if for some reason it's not in there, let's just continue. Otherwise, we're going to do sprite.destroy. And we're going to remove sprites by ID, delete ID, just to clean up if we're removing that component from the entity. That's how cleaning up would work. That's the exit query in bitECS. So now we'll just review here what we've done. So we created a system. This is our sprite system. This is how we're basically rendering things, since we're leveraging Phaser for all the rendering. And in most cases, we'll also use it for any physics. If you were using Phaser with bitECS here, you will likely want to also just use the physics system in Phaser, since it has two really good ones. Matter, it has arcade physics. You're probably familiar with them already. There's no reason to roll your own physics, but you still could if you wanted to in this ECS system. You would just use Phaser only for rendering if that's what you wanted. So we have this map of sprites. This could be a group of sprites too, just depending on how you want to set it up. A Phaser group, I mean. And so in our sprite system, we have a query, and what it does here is gets any entity that has a sprite and position component. That's what this array here is. Then we do that enter and exit query like we talked about, so that when a new entity has been given a sprite component, it's going to be in that query. When it's been removed, it's in this query. And that's our sprite system that's going to run in the scenes update. And then to create entities and to add components to them, we first make a world, then we call add entity to make an entity, which is just an ID. Then we add components on that entity, like this, add component, give it the world, the component we want to add, the entity ID that we're adding it to. Here's how we index in to the positions array, or the positions X and Y arrays, to set the values of X and Y for that entity that we just made. And we do the same for velocity and for a sprite here. And for the sprite system, because in bitECS all the properties on our components are going to be numbers of some kind, assigned, unsigned, float, or ints, we're going to use unsigned numbers here. So this is 0, which corresponds to tank blue. What we should do is make an enum or something else so that we can just go, tanks blue, it's 0. So it's easier to read. We'll do that in the next video. So that's what we did here. We just did a basic setup, and if we were to move this, you'll see that our tank is going to move 100 pixels to the right here. So this is all in fact working. So we've got the basic ECS system using bitECS working in Phaser 3. Now if you enjoyed this video, be sure to hit like and subscribe to the channel. It is the best way to support Arcade so that we can continue making these videos on making games on the web using Phaser, Kaboom, and other web technologies. Now be sure to come back for part 2, where we're going to handle moving our tank around here with the arrow keys in this ECS system with bitECS. and Phaser 3.